Hi everyone, this is Mr. Kasinga. So if you're a student, you're at college, or you're doing addition mathematics, this video is for you. Now we have this question here. Find the independent of x in the expansion of, open the bracket, 2x to the power of 3 plus 1 over x to the power of 8. For you to answer this question, you just have to know two concepts. So the first concept, you have to know the laws of indices. Then the second one, you have to know the binomial theorem. So for the sake of interest, the binomial theorem states that if you have a plus b to the power n, where n is not equal to 0, then your expansion will be a power n, then plus n combined r, then a to the power of n minus 1, then times b to the power of 1 plus n to the power of 2, then a n minus 1 times b to the power of 2. Let's say now, if we want to change to a known term, let's say we have n power r, then we have a, n minus r, then b times r. This, when we add and so on, it will end just to b to the power n. Now this expansion is what we call the binomial expansion, and for you to understand it fully, we just have to look at the topic in details. Okay, but if you're not conversant with the binomial theorem, you can use Pascal triangle. Okay, so for the Pascal triangle, it uses the coefficients. Okay, so but in this video we are not going to look at the Pascal triangle. So let's look at this question now. They say we find the independent of x in the expansion of this term. So we say solution. So let's say we have n combined r. What we do, take the first term, which is 2x to the power of 3. So we say 2x to the power of 3, then n minus r. Then this we multiply with 1 over x to the power of r. So what I've done here, I've just used the concept of the binomial. Now from here, we are going to say let n to be equal to 8. Now n should be 8. Why? Because this n represents the power. Remember I said if you have a plus b to the power n. Now this n, it represents the power. But in this case, this 8, that is n. You see that? So since this 8 is n, that's why we say let n be equals to 8. If here there was a power of 12, we could have said let n be equals to 12. Okay, now let's solve the question. So what we do here, we are going to say n combined r, it is going to be maintained. Now this 2, it is being affected with n minus r, as you can see. Again, this x is being affected, this x power 3 is being affected with n minus r. So we'll say that we have 2, then n minus r. Then this multiplied with x power 3, then n minus r. This x is also affected with that. That is just the laws of indices. Now from here, I want you to pay attention. We have 1 over x. This is where the laws of indices will start getting applied. If you have 1 over x, according to the laws of indices, 1 over x is the same as x to the power negative 1. You see that? Provided x is not equals to 0. So we have x to the power negative 1, which is the same as 1 over x. Meaning here, where there is 1 over x, I want to rewrite it as x to the power negative 1, then times a power of r. So this is why I was saying we are going to use the concept of indices. So it is very important to understand all the concept in ordinary mathematics before you start doing addition mathematics. So from here, we continue solving. So we say that where there is n, we are going to replace with 8, since we select n equals to 8, which means here where there is n, I'll substitute with 8. Again, here where there is n, I substitute with 8, and there, just like that. So we say we have 8 combined r, then we have 2, where there is n, 8, then minus r, times we have x to the power of 3, then 8 minus r, times x, this one you can just say negative 1 times r, which is negative r. Now, the question says we should find the independent of x. Sometimes they can say we find the independent term of x. Now what we do is that the only independent term of x in this expansion can only be found if we equate this to x to the power of 0. Since x to the power of 0, it will give us a 1, but in this case the only independent term of x can only be found if x has the power of 0. Okay, if you want to, you can just put it direct if x is equated to 0, but it will make more sense when you say x to the power of 0, so that all the bases here, you're going to have the bases of x. Okay, now when you have the bases of x, I want to put a line like this. You focus to the right hand side. This is where the bases are. When the way I've separated here, as you can see, I've moved the power of x, the base of x, the base of x, and the base of x. So what we do is that we have this 3, it is being multiplied with 8 minus r. So we say 3 times 8. So 3, it is being multiplied with 8 minus r. Now remember, when we are multiplying the bases, which I say, according to the laws of indices, we add the powers. So I'm going to say we have positive, then negative r equals to 0. I've equated to 0, since when the bases are same, you equate the powers. Then this plus is coming as a result of the laws of indices. We say we have b to the power 2, then times b to the power of 2 is the same as b, then 2 plus a 2. That is the laws of indices. Okay, now from here, what we do is say this 3 you multiply with 8. So this 3 times 8 is simply a 24. Then again, the same 3 you multiply it with negative r, you get negative 3r. This positive times negative, you just get negative r equals to 0. Okay, when you reach this stage, you just have to identify the terms that you can subtract or add. So as you can see, this 24 will remain where it is, but negative 3r and minus r, it will give us negative 4r, then equals to 0. So to give us negative 4r, then equals to 0. But these are unlike terms. So what we do, this 24 should go to the other side, so that we remain with negative 4r. Because when this 24, I take it to the right hand side, it becomes negative 24, since it has crossed the equal sign. Then from here over negative 4, and this side over you divide 4 out of negative 4. Our r is negative and negative is a positive. Then you say, how many times can 4 go into 24? That is 6 times. Okay, so therefore r is equals to 6. Now, the question says we should find the independent term of x. They don't want, it's not asking for the value of r or the value of k, whatever it may be. But this value of r, it is now going to help us find the independent term of x. So, look at here. I had splitted here to say we are going to take the terms which have the base of x, which means this term or expression, we didn't use it. So we are going to use this term to find the independent term of x in this expansion. So this is what we are going to do. So let me erase this part of the board. And here as well, we can grab, and here also. Okay, so this remaining term, which is here, it is the one we are going to use, of which we have 80 combined r, then times 2, then 80 minus r, this. Now remember, we had found r to be equals to 6, so r will be needed. So what we do, we say we have 80 combined r, which means where there is r, we replace with 6. So I'm going to replace with 6. Then 2, 8, where there is r, we replace with 6. Then I'll say 8 combined 6. Then here 2. What is 8 minus 6? So from 8 we take away 6, that is a 2. Now when we reach this point, this is where now we have to use a calculator. So get a calculator. So I have this calculator here. So this is my calculator. So this term 8 combined 6, I want to show you how it is done on the calculator. So you start with 8 here. I'm going to replace 8. This is 8. Then the combined symbol is here where there is NPR. Combined. Then you just press 6. After that you press equal sign. You find 28. So here I'll have 28. Then multiplied by 2 to the power 2. It means 2 times 2, which is equals to 4. So here we have 4. Then 28 times 4, we'll just say 28, then times a 4, and you find 112. So here we find 112. So meaning the independent term of x in this expression, it is 112. So thank you for watching this video. Remember to comment and to share to your friends so that they can also benefit.